Welcome to a short presentation on Atmel's latest touchscreen controller entry, the MXT540E, as well as a quick comparison to its predecessor, the MXT224. Hi, this is Jericho Garcia, one of the design analysis engineers working for the circuit group of Chipworks. Atmel's venture into the touchscreen market paid off with record growth in its microcontroller business segment. In fact, Atmel's 2011 letter to its stockholders mentioned that its capacitive touch solutions, which is represented by its MaxTouch touchscreen controller product line, registered the highest growth area within the segment. Previous research and articles written noted the extensive design wins of the original MaxTouch device, the MXT224, in the high-end smartphone market. Now, not being complacent about this win, Atmel came up with a new series of products to build on this advantage. Welcome to E series of MaxTouch devices. We might as well interpret the E as being enhanced, since every aspect of this touchscreen performance has been improved according to Atmel's product briefs. Chipworks' own process analysis of the MXT540E resulted in the following feature updates, as you can see here on this table. If you notice on the technology node, there has been a process migration from the original MXT224, which comes in a 0.25 micron process, to the 0.18 micron process adapted for the MXT540E. Also notice the marked increase in die dimension between the MXT224 and the MXT540E. Die used in the MXT224E, the MXT540E, and the MXT760E, which is part of this E series, are all the same. Circuit reverse engineering using Chipworks' proprietary tool, the ICWorks Browser, was also conducted to determine the schematics comprising the analog front-end portion of the chip. Here you can see a full die photo of the original MaxTouch IC, the MXT224. Shown here in the image is the areas extracted by Chipworks before, which pretty much covers the AFE of one channel as well as the ADC. Now shown on the screen is the partial image as well as partially annotated die photo of the MXT540E. We have actually focused only on one of the channels, and we've pretty much disregarded the ADC portion of this chip for now. So what are the notable differences between the AFEs of the MXT540E and its predecessor, the MXT224? Well, for one, the preamplifier, the MXT540E, takes in two acquisition signals. One here, another here. Now let's descend below the preamplifier schematic to see where these signals go. These two signals go into the input of this preamplifier. Now let's compare that to the preamplifier found in the MXT224. Here you will see that this preamplifier actually takes in only one signal coming from the acquisition pins. Now descending into the preamplifier schematic would show where exactly that Y acquisition signal go into. Another notable difference is the way Atmel has done away with precision current mirror stages. That is to say, these current mirror stages make use of amplifiers to equalize drain to source voltages for higher output impedance. Well, compare that with the biasing for the preamplifier found in the MXT540E, where Atmel simply made use of cascaded current source to also come up with increased output resistance. Another notable difference is the increase in the size of the slew rate control circuitry. Here in the, as you can see here in the MXT224 schematic again of the preamplifier stage, you can see here the slew rate control circuitry controlled by a 3-bit input control signal. Now let's compare that to the slew rate control circuitry found in the MXT540E. Here in schematic 2.0.0, you would notice that instead of the 3-bit input control signal, we actually have 4 bits now. Let's descend into this slew rate control circuitry at the output stage of the preamplifier. You would see that the circuit dedicated to the slew rate control itself is a lot bigger than the one found in the MXT224. Each one of these selectable drivers, It's actually composed of a number of transistors that are basically being controlled by this significant control logic block. Now, one noted similarity between the MXT224 and the MXT540E is the use of the common mode feedback circuitry in the charge integrator amplifier. Here in the MXT224, we could see where that charge amplifier is by going down to schematic 8.0.0 and then down to schematic 8.3.0. Here at the very end of the amplifier is our common mode feedback circuitry. Now the same type of circuit can be found in the MXT540E. Let's go down to the charge integrator circuit schematic 4.0.0 and go here to this charge integrator amplifier schematic 4.2.0. Shown here at the very end is our common mode feedback circuitry also. That pretty much wraps up the differences noted in the MXT540E and its predecessor, the MXT224. We hope you learned something from this short discussion on these two touchscreen controllers by Atmel.